In this lesson, we will learn how to train a sentiment classifier. We are going to use an annotated list of positive and negative sentiment words and a pre-trained word embedding. In order to classify words, we need to convert them into numeric vectors. The pre-trained word embedding does this conversion for us. We are going to implement the entire system in 5 steps. At the first step, we will load the pre-trained word embedding. In the second step, we will download the dataset. In the third step, we will load the positive and negative words from the dataset. In the fourth step, we will train our sentiment classifier using the word vectors of the positive and negative words. And finally, we will test the classifier and express the predicted positive and negative sentiments graphically. I believe you are very excited about this lesson. Let's get started. To keep things organized, create a folder in the desktop or wherever you like. Then name it Sentiment Classifier. Now open your browser and go to cs.uic.edu/tilde/lib/sentiment-analysis.html. You can find the link in the description of this video. We're going to download the dataset from here. Click on this opinion lexicon. Here is our dataset. Click on it to download it. I'm going to save it in our sentiment classifier folder. The dataset has been downloaded. It is a rare file, so we need to extract it. Let's extract it here. We no longer need this file. I'm going to delete it. Our dataset is ready. Now launch the Matlab. Then locate the sentiment classifier folder in the current folder window. To do it, click on this Browse for folder icon. Then go to the desktop or wherever you have created the folder. This is my sentiment classifier folder. To locate it in our current folder window, simply select this folder and click on this Select Folder button. Now we can see the sentiment classifier folder here. It is time to do the coding. To start, click on this No Script icon. Then click on this Save icon and save it as Sentiment Classifier. In this lesson, we are going to use a pre-trained word embedding. Now I'm going to load it. For that, I need a variable. Let's name it EMB, which is actually the short form of embedding. And the function that is going to load the pre-trained embedding is fast text word embedding. In order to use this function, we need to have 2 support packages. They are Text Analytics Toolbox and Text Analytics Toolbox model for fast text English 16 billion token word embedding. To get these support packages, go to the Home, then click on this add-ons icon. The add-ons explorer will appear. Here, type text analytics toolbox and click on this search symbol. Here are two add-ons, those we need to install to use the fast text word embedding function. Both of these packages are installed in my Matlab. That is why the installed notifications are here. If these two notifications are not here, then install these two add-ons. After installing this, you'll be ready to go. I'm assuming that you have installed the necessary support packages and we can use this fast text word embedding function now. So, why we are using this function? It actually returns a 300-dimensional pre-trained word embedding for 1 million English words. You may wonder what word embedding exactly is. Let's have a simple idea. Word embedding is mapping words to vectors of real numbers. Here is an example of three-dimensional word embedding. Here, this particular vector represents newspaper, this vector is for magazine, and this vector is for biking. Notice one thing, the distance between newspaper and magazine is not that much because they are similar. On the other hand, there is significant distance between magazine and biking because they are not similar. That means we can classify the words based on the distance. As these are vectors, we can make decisions based on vector operations as well. This is an example of three-dimensional word embedding for 3 words. This fast text word embedding function returns a 300-dimensional word embedding for 1 million English words, and that is why we are using this function. Now we need to load the dataset in Matlab's workspace. If you are not familiar, this is the workspace. Let's create a function to load the dataset in this workspace. To do it, click on this plus symbol, then click on this save icon. Name it read lexicon or whatever you like. Then click on this save button to save it. At the beginning, we need to define the function. We start with the keyword function. Then we need to give it a name. The function name here and in the current folder window must have to be the same. Otherwise, it will not work. That means we have to write read lexicon. This function will return data. Let's take a variable named data to store what this function returns and to use it later on. Alright, the function has been defined. Before going forward, let's examine our dataset. The dataset is in the Opinion Lexicon English folder. Click on this plus symbol. We can see there are 2 text files here. One is negativewords.txt and another one is positivewords.txt. Double click on any of these files to open it. I'm opening the positive word file. The semicolon enclosed area is comment section. This is not the part of the dataset. These words are actually the data. Close this file and get back to the lexicon read function. At the beginning, we're going to read the positive words. To do it, we need to open the file. We use fopen function to open a file. Inside it, we're going to use another function named full file. The full file function builds the path to a target file based on the argument. Our target file is positive words.txt, and it is located inside the folder named opinion lexicon English. Now this full file function will generate this path. Let's copy and paste it in the command window to see what it is actually doing. See here, we got the path to our target file. This fopen function will generate an identifier for this file. We're going to store this identifier in a variable named FID positive. You can use any other name, whatever you like to write, but I'm using FID positive. Now terminate this line with a semicolon. Now it is time to scan the data of positiveword.txt file. To do it, we are going to use text scan function. The first argument will be the file identifier, that is FID positive. We are dealing with strings here. We need to specify the string data type in the second argument using %s. In the text file, there is a comment section at the beginning. We need to exclude it. To do it, in the third argument, write comment style, and in the fourth argument, type semicolon, which is actually the symbol of the comment in the positivewords.txt file. Now terminate this line. This function will return the data located in positivewords.txt file. In order to store this data, we need to take a variable. Let's name it C. Now the data in C variable may include some numerical values. Let's use string function to convert everything stored in this C variable into a string. This one generates a single column output. Now this function will give us only string. Even if there are dates or numbers, it will be converted into string. Let's store this string data in a variable named words positive. We're going to do the same thing for negative words. Instead of retyping, we're going to copy this block and paste it here. Now change these positives to negative. This section is ready. We have two files open here. Let's close them using close all command. The positive words and the negative words are in two separate variables. Let's combine them together and store the combination in a variable named words. In this combination, the positive and negative words have not been labeled. Let's categorize the data with two labels, positive and negative. To do it, take a variable named labels or whatever you like, then use the categorical data type. We need to find out how many values will be categorized. We use numL function to calculate the number of elements of a variable. Here, the data are stored in words variable. Now this will give us the number of elements stored in words variable. Instead of keeping the value field empty, let's fill it with none value. Then add 1 here to convert it to a single column. We need to label the positive words as positive and negative words as negative. To do it, type labels, then write 1 colon numL, and inside the bracket write words positive equals positive. This line is assigning the label positive to all positive data starting from 1. Then type labels again. This time we're starting from the value of the last positive words. That is why we're writing numL words positive plus 1. And we're going to assign negative label till end. The data have been labeled. Now we have to create a data table. We can do it using table function. The first argument of this function is the words. And the second argument of this function is the labels. And the variable names in the table will be word and label. Let's store this table in a variable named data. Do you remember this variable? This is the variable which will be returned by this function. Alright, our function is ready. Go back to the sentiment classifier. Now, simply by calling read lexicon function, we can load the dataset in Matlab's workspace. This function returns a set of data. To store them, we need a variable. Let's store the output of read lexicon function in data variable. Let's see if the function is working properly or not. Take a variable named idx or anything else you like. We're going to load the data in this variable. Our target is to load the data that has labels positive. By writing dot label, we are accessing the labels of the data, and by assigning positives here, we are loading only those data that have positive labels. Now I want to show the data including the head. That is why I'm using the head function, and this function will show the data. Those are in this variable and which has labels equals positive. And I'm going to use comma colon here so that all the data is loaded row by row. Now let's copy this section and paste it here and change this positive to negative. Now we will have both positive and negative labels. If we run this code now, everything will work fine. However, we won't be able to see anything because these two lines are terminated. Let's remove this semicolon here and run this code to see what happens. We can see the data with positive label and data with negative label have been loaded. And because of using this head function here, we can see the head here. Now it is time to prepare the data for training. To train the sentiment classifier, we need to convert the words to vectors using pre-trained word embedding. However, our pre-trained word embedding does not have all of the words of the world. That is why we need to check and remove words which are not in the vocabulary of the embedding we are using. To do it, take a variable idx, then use this not symbol and write is vocabulary word. It means words which are not in the vocabulary of this EMB. The words we're talking about are stored in data variable. We already know that this data variable is actually a table, and the data of the table have been labeled with label and words. We are interested in word this time. Let's terminate this line. So this line will take care of the words which are not present in EMB, and it will discard those. Before moving forward, let's convert the data row into an array. In our training process, we're going to set aside 10% of the words for testing, and rest of the 90% of the words will be used for training. Let's start by counting the number of the words we have. We can use the size function to count the number of data at the first column. And we're going to store the number of data in a variable named numWords. Now we are going to use this CV partition function. The first argument of this function is the number of words we have, and we want to hold out 10% of the data. Let's store the output generated by this function in a variable named CVP. You can use any other name you want. Now create a variable named dataTrain, and it will be used to store the data we're going to use for training, and how many data we are going to use for the training will be defined by this CVP function. And we want to keep the data row by row. That is why I'm using this comma colon here. Let's terminate this line. Now copy this line and paste it here. Change this train to test. And here, instead of training, write test. Now, this variable will store the data for testing. It is time to convert the words into vectors. Create a variable named words train and then assign this data train to it. Actually, we don't want all of the data. We want the words only. That's why I write dot word to access the words only. Now terminate this line. Now we have only training words in this variable. Use word to vec function to convert the words into vector. We need to supply the pre-trained word embedding, which is stored in this EMB, to this function, and we need to specify the training data which are stored in this variable. Now store the result returned from this function to a variable, say xtrain, and terminate this line. We need the labels of the data too. We can read the labels of the data train by writing data train dot label. Let's store the labels in a variable named ytrain and terminate this line. Now we are going to train a support vector machine classifier to classify the vectors into positive and negative categories. We use fitc SVM function to do that. The first argument is going to be the training data, and the second argument is going to be the labels. Let's save the return classifier in a variable named MDL and terminate this line. Now use the save function to save everything we're doing. Let's name it sentiment classifier .mat. Terminate this line and run the code. It will take some time to complete the training process. The training is completed. Here is our saved structure. It is time to test the classifier. Let's create a new script and save it as test classifier. At the very beginning, we need to load the structure. The name of the structure is sentiment classifier.mat. Let's use a variable to store this structure, and the name of the variable is saved network. Here the sentiment classifier.mat is actually a structure. It is not the classifier, but it contains the classifier. Let's run it and see it for ourselves what is actually inside this structure. Type saved network here and press enter. This is the structure. Here we have everything that we did in our previous script. we need this support vector machine classifier. Let's load it. Take a variable named trained SVM and copy the name of the structure and access the SVM with this dot and write the name of the SVM classifier, that is MDL. Now the classifier is stored in this variable. Take a variable named words test and we're going to load the testing data here. Take a variable named xTest and use word to vec function to convert the words of this variable into vector using EMB embedding. Terminate this line. Take another variable named yTest and load the label of the testing data. Now we are going to use the predict function to predict the output of our classifier. Our classifier is stored in this variable and our testing data are this xTest. This predict function will return the predicted label. Let's name it yPred, and it will also return a probabilistic score. Let's call it scores. Now I'm going to display the result in a figure, and the figure is going to be a confusion chart. The first argument of the confusion chart is the yTest, that means those are the labels, and the second argument is going to be our predicted labels. Terminate this line and run the code. This is the result. We have 180 true positive. That means our model predicted it as true and they are actually true. However, we got 13 false positive. That means our system predicted them as true, but actually they are false. Here we have 442 true negative. That means they are actually negative and our system also predicted them as negative. And we have 17 false negative. That means these are actually negative, but our system has predicted them as positive. So this is how you can train a sentiment classifier using support vector machine. You can download the code using the link below. And if you find this video helpful, please subscribe my channel.